In this video, we are going to see the design and detailing of the previous 2D frame. Okay. So now let us go for the design after analysis step. So click on design. Go for concrete frame design and we need to specify the preferences. Okay. So either we can go for view or revise preferences to see the code and other factor of safeties and gamma for the steel and concrete. So here it has been already defined there. Okay. In the starting we have given the code, so according to that it has been taken. So click on OK and just click on design. Again you can go for the concrete frame design and you can go for the rebar selection rules for columns as well as for beams. Okay, so you can go for columns and whatever the longitudinal bar sizes of minimum and maximum sizes you can define that here. Okay, right now I'm just going for non-seismic requirements. Okay, so smallest bar sizes, let us go for smallest I want to give 12 for the column. So minimum size required for column is 12 actually. So let us go for 20 as the maximum size for this structure. And the thigh bars are 8, smallest bar, and the largest bar is 16 here. Minimum and maximum spacing. So maximum spacing is 300 mm. Click on OK. Similarly, just again go for design, concrete frame design, and just go for the third option, selection rules for beams. And under non-seismic requirements, just go for the smallest bar. So I want to go for the 10 at top, and at bottom I want to go for 12. So largest bar, let us go for 20 for both top and bottom here. And preferred size I am going for 12. Okay, preferred size is 12 for the beam. And minimum number of bars, yeah, let it be 2 for beams. So as per the given loading conditions, it will be changed. Okay, so stirrups, I want to give the minimum size as 8 and the maximum size as 16. And the maximum size is changed to 300 as per the codal provisions. So click on OK. And let us go for design, and you can click on concrete frame design. We can start for the design. Okay, so you can check the view preferences. Already we have done that here. Okay, so click on OK. Now go for design, concrete frame, and just go for the start design or check. Okay, and here we are going to have the select design combination. Already we have specified the combination, right? I said we can assign this in the design. Okay, so just select this and click on the double arrow, click on OK, and the combinations will be assigned for the design purpose. Okay, it will be selected for the design purpose. Now let us go for the design, concrete frame design, and we can go for start design or check. And its shortcut key is Shift plus F6. And you can see that the design has been run, and whatever the values we got on the screen here, so these are indicating the AST. Okay, now let us go for detailing. So click on detailing, go for detailing preferences if you wish to change. So these are the units. Okay, so the rebar length is in mm and the weight is in ton. So concrete volume is cubic meter or meter cube. So let us click on force and change it for kilonewton here, and yeah, all others are okay. So click on OK. Now go for detailing, and you can go for start detailing options. Okay, or if you want to set any preferences, go for concrete component preferences. You have to select the beam and column. So let us go for beam. So it is indicating the label prefix as CB here. If you want to show the section name, you can go for the section name also. Okay, similarly you can go for the column, the prefix is CC. If you want to change it, you can change it there. Okay, so click on OK. Again go for detailing, and here you can go for rebar selection rules for the beams and columns. Okay, so I'm going for the beams now. So it is showing the smallest and largest bar preferences. Okay, so mostly it will be showing the default settings. So if you wish to change, you can change it here for each and every zones. Okay, so let it be default values for now and click on OK. So let us change it for 28 only. So these are the default values. So whatever you need, you can change for the non-seismic or seismic for the columns. Okay, so there are different zones. So whatever you want to change, you can change it here. But for this example, I'm going to consider the default values. So clicking on OK. Now again go for detailing, and I'm going to click on the start detailing. Okay, so the detailing has been run, and under detailing, under model explorer, we are going to have the detailing tab. So click on that, and it will be opened by default. So you can expand the drawing sheet component views. and you can go for the standard details. So list of drawings, what are the list of drawings we are going to have. So under this I'm going for typical concrete beam elevation, or we can go for beam section A, how it will be looking. Okay, so it will be showing here. Similarly concrete column. So let us observe this here. I'm just going to resize this and I'm going to restore the full view here, or else we can just zoom in this view. Okay, so here we can see that this is zone A up to this, and zone B, and similarly the middle part is zone C, and again zone B and zone A. Okay, and here it is indicating with the arrow mark. Okay, that is like a zone B, I mean like not B, so this is indicating the B, this bars. Okay, and the inner bars are indicating the G, and these are indicated by F, and the spacing between the top and the section is indicated by H. Okay, so the effective depth is indicated by D, and this is indicating this is indicated by capital D. Okay, so these all things we can observe in the table. Okay, similar way we can go for the column concrete column also. Here also we are going to have the different zones. Okay, so maximum, I mean how the zones has been defined. Okay, what is meant by H1, or what is meant by tie zone B, tie zone A. Okay, so here we are going to have the column section A also. What does it indicate? So if you are going for concrete beam, under notes you can see that C beam schedule for stirrup type and spacing. Okay, zone A length shall be twice the beam height. How they are taken, how those zones are defined, etc. can be noted here. Okay, the first stirrup in the zone A shall be located at 50.mm maximum from the face of the, so you can use the pan, so just you can drag it towards the left, so maximum from the face of the support, and the lap splices should not be located within the beam or column joint. Obviously we can't splice between the nearby joints. Okay, and the splices shall be enclosed by the hoop stirrups at maximum spacing of D by 4 or 101.6 mm. Some notes has been provided. Okay, you can just check it here. For our column, for whatever the structure we have given there, if you want to observe for that, then you can go for beam details. Just expand this, schedules and table, click on this, and we got the schedule table here. So beam ID, so this is the CB which we have seen in the detailing preferences. So it has been given as 2CB1, and span number is 1, and span length is 3.55 meters, since from we have assigned from column to column. And I'm going to use this span. So span length, width and depth factors also been given there. I mean whatever the cross section properties we have assigned, that has been shown here, and A, B, C, D are indicated on the this figure, right? So we are having A, B, C. So we can see this on the screen also. Okay, so let us compare this one. So A is indicating 2 bars of 14 diameter and 206 is AST, like that. So under B, C, almost all are same. And under F, so where is F located here? Yeah, in the middle, the bars has been provided as 4 numbers. Okay, so we got the 414 here. So let me use the pan again. So just you can drag it here. And L1 and L2. So let us see L1 and L2. So this is the L1 zone, I mean L1 length. Okay, so this has been provided as 0.887 meters. Okay, so this is for seismic zone, that is that we don't require right now. I mean after this we are going to have. So here zone A, zone B, zone C, for that one stirrups has been provided. Actually it's showing seismic, but it will be shown for the, I mean we are getting the results for the defined properties. Okay, so for stirrups it has been provided 310 at 125 mm type A. Okay, and similarly at zone C it has been provided 26 bars of 10 dia. Okay, so let us see that zone C is here. Okay, and zone B is here. Yeah, zone A is here. Okay, so in this way we can see the detail. This is just an example, and after some videos I will be showing some one detailed example. There we can learn this all the things. And similar way we can go for the column sections also. So just going for the frame plans, you can go for the concrete top view. Okay, and you can go for the schedules and tables. You can find out the column sections, I mean column related schedules. Here what it is indicating, column size is section. Okay, reinforcement, so it has been provided with 14 diameters. Okay, 12 bars of 14 diameter of 828 AST. Okay, so tile zone A 10 at the rate of 10 diameter, sorry, 100 spacing. Similarly, ties zone B, ties zone C, it has been same here. We can interpret it by seeing this column drawing. Okay, so under this we are having the concrete, right? So concrete column, go for the concrete column typical elevation, and you can see that we are going to have the tie zone A, tie zone B, etc. Okay, according to this, the tie zone, tie beams has been provided. In column, this stirrups are known as ties, in beams it is known as stirrups. Okay, if you want to see cage view of this one, you can just expand the cage view here under the detailing tab. Go for the beams and you can click on 2CB1 since we are having only one beam, and it will be indicated here. So let us go for the restore full view, and let me expand this. We got the cage view like this. Okay, and here similarly we can observe the column also. Let us go for the column, just click on this. So we got the column part also. Okay, so just it is showing some 3D view of the rebar. Okay, so this is not exactly that what we got. So it is just indicating the cage view of the detailing part. Okay, so just if you are holding the cursor and moving on the screen, we can rotate that column section here, column rebars. Okay, so in this way we can observe the detailing of the given 2D frame.